Does it look like a holiday to you? Actually, I'm measuring the current. This is a clamp meter, a device that was meant for one use and one use only, to measure current. But just like cell phone, which had one job and one job only, now the clamp meter can measure current, voltages, resistance, temperature and more. So here we have a portfolio of unity clamp meters with different functions that will satisfy your needs. And shut up, if they don't, just let us know. There are a few reasons for using a clamp meter when you are measuring current with the digital multimeter, where the current has to go through the multimeter. Possibly like this, right? But in some situations you cannot simply shut down the whole system, cut the wire, connect the multimeter. And this is especially dangerous if we are talking about hundreds of amperes. Well, the clamp meter doesn't need to touch the live wire to understand what current flows. You see? It somehow senses the current. This plays a huge role in efficiency and safety, as some currents can reach hundreds of amperes. But this is also the downside of a clamp meter. Due to the reason, the measurement is through conversion, not directly. It is not as accurate as a direct measurement taken with the digital multimeter. There are two main types of clamp meters, those that can measure AC and those that can measure AC and DC. AC clamp meters use a transformer, whereas AC-DC clamp meters use a Hall effect sensor. Let me explain. AC clamp meters or current transformer clamp meters are cheaper but not as accurate as Hall effect clamp meters. In order to measure current, they use the same principle as in transformers, electromagnetic induction. In this case, the primary winding is your conductor and the secondary windings are the coils around the jaws. They are inside and you cannot see them. When an alternating current flows through the conductor, it generates an alternating magnetic field, which is concentrated by the core and induces a current flow in the secondary windings. For instance, if our primary winding has only one turn, the secondary winding has 10 turns, and the current that flows through the primary winding is 10 amperes, then the reading will be 0.1 amps. Because the signal is proportional to the ratio of the windings, I can measure very high current by making hundreds of turns on the secondary windings. But what kind of magic is used to measure direct current? If it looks like sorcery to you by now, do not be afraid to ask questions down below, because the next part is not as simple as taking a rabbit out of the hat. In order to measure AC and DC current without touching the live wire, we have to go back to 1879, when Mr. Edwin Hall discovered that when current flows through a conductor in a magnetic field, it generates voltage between the two sides of the conductor. This bulky piece in the middle is our conductor. The battery provides the voltage and current starts to flow. If we put it into a magnetic field, the electrons will be attracted to one of the sides of the conductors depending on the direction of the magnetic field and create a potential difference. This is called the Hall voltage. Today, we simply use a Hall sensor that measures the magnetic field, which is generated by the current flow through the wire. Because the Hall voltage is proportional in size to the current and magnetic field, it is easy to convert it to amperes. If you already know how to use a clamp meter properly and you know where magnets come from, you can go to TME's website and select the clamp meter of your dreams. But if you are not sure where magnets come from yet, just wait for it. When you measure current with a regular multimeter, you measure the current only on one wire, not two. This also applies to clamp meters. If I measure AC around the wire, well, I get no readings because the current flows in two different directions, which is sort of cancelled and cannot be detected by the equipment. If you are not sure what current you're about to face, start from the highest range and go to the lowest for more accurate readings. And if your clamp meter uses a Hall effect sensor, make sure to zero the readings just before the measurement because of other magnetic fields that can influence it. One more trick. Can you tell me what happens if I take not one, but more turns of the same wire? Will it increase the current, or perhaps they will cancel each other? If you understood the working principle correctly, you should be able to tell me that. Well, first of all, the current consumption won't change. It's the same measurement that rises each additional turn. This is useful when the current is very low. Just don't forget to divide the measurement by the number of turns. So, do you know where magnets come from? They grow in magnetic field. I can measure every very high slide, bla la la.
No czerwona jest.
Co ty gadasz?
Kot?
This is called the Hall voltage. Voltage.
Hey, one